Hello everyone, I'm Mithun Chakravarti. In this Practicum 10 of our computer organization and architecture, we are going to briefly see about the temperature display system. Temperature control is a fundamental requirement in the industrial automation. HVAC system, chemical processing, biomedical equipment, and smart manufacturing. Precise closed loop temperature regulation ensures the product quality and process safety and energy efficiency. So in this practicum, we're going to introduce students to design the simulating of a temperature control system in the MATLAB Simulink using the Simscape thermal library combined with the continuous time PID controller. So the model mirrors a real-world closed-loop control scenario where a set point, constant block defines a desired temperature. The PID controller computes the corrective action, a controlled temperature source applies the heat input, and the temperature sensor measures the actual output. The error signal continuously derives the controller minimize and the deviation from the set point. So by simulating the system, students is going to develop the critical skill of translating the physical control theory in the executable. So the verifiable models are directly applicable in the industry process control. So the embedded thermostat design, which is going to be the PLC programming. So when we come to the circuit diagram, so this is the main circuit diagram of the Practicum 10. So let me explain you this diagram. So here there's a constant which is the input reference signal where we are initializing setting it to 8 for just an example where the temperature is going to be 8 units. And next is the summation block, which is the error calculation. So this calculates the error, which is equal to set point minus feedback. So the PID controller, which is the used to it is going to use to process the error using proportional integral derivative, which reacts to the current error, past error, and the future error. So the output is going to be like control signal sent to the system. So next is the signal conversion, which is from the Simulink physical part. So the small arrow like block from PID is the Simulink PS controller, which converts the mathematical signal to the physical signal, which means the logical signal to the physical signal. And in the next is the physical system, which is the orange part of the Simscape, which is the actual plant system being the control. So the components are control source, electrical physical network, ground, and the error block ABT. And next is the feedback path where the sensor is output goes through, which is the PS Simulink controller, which is then it feeds back to the simulation. So this PS Simulink converter converts from physical to the digital signal. So and finally we are displaying the scope where the small screen and the constant block provides the reference for grounding where f of x equal to 0. So this finally calculates like maintains the temperature between the constant value which is given as the input. So this is the graph output of our Practicum 10. So thank you.